There is something different about LLMs compared to other machine learning models. They take a long time to return the full answer. It can take many seconds. So, what do we do then? We just wait in front of a spinning wheel? Nowadays, people don't have the patience to wait for a few hours a package to be delivered by Amazon Prime. Do you think they are going to wait for an LLM to provide a response? The solution to that very peculiar problem is to stream the response as it is being generated. Let me show you how. If you are deploying a large language model that is meant to generate text, then it might be a good option for you to build an application that has streaming capabilities. So you notice that when you use an application like ChatGPT or Claude, you will have the text that is streamed to the browser, meaning that the text appears little by little, token after tokens. Very often, decoding a whole sequence takes a lot of time, and it would be a very bad user experience to wait for the whole sequence to be decoded before sending it to the user. So the streaming text generation is often very necessary to make sure that the user experience is good. So let's imagine that we have a user and is using a client. So here is a browser, and we have the LLM that is deployed on a server. So the user is asking a question, how are you? And is expecting the LLM to answer back. So the how are you request is sent to the LLM. And what you would see are the tokens being generated one after the other on the screen. And you don't have a lot of latency in between you send the request and when you get a response from the LLM. So here you have the first token, I am good and you, question mark. So you see the tokens are sent sequentially to the browser, and this is called streaming. So what are the different strategies to enable streaming when you are building a large language model application? Well, the first option, the most common option, is HTTP request. So let's see if it is a good option. We get a HTTP request, so we send the request, how are you, to the LLM, and the LLM send a response. So HTTP requests are good to get one response from one request, because after we get the first response, the connection gets closed. So this is not the best option when it comes to streaming. With HTTP requests, you can have long pooling and you can wait for responses to be sent to the user, but it's not the best option to get a streaming application. So not great for streaming. So let's look at WebSocket connections. So WebSocket connections start with a HTTP request, and the HTTP request get upgraded into a WebSocket connection. So a WebSocket connection is some kind of tunnel, some kind of channel where messages can be sent back and forth between the user and the server. So WebSocket connections are good for interactive connections between the user and the server. For example, if you have two users talking to each other, it might be good to use a WebSocket connection because messages can be sent at any point in time by the two different users, and you don't need to wait for a request to get a response from another user. But in the case of a LLM, what happens is that you have a response when you have a request from the user. Typically, it's what happens. So a WebSocket connection may not be the best option when it comes to getting a streaming capability. So typically, the best option when it comes to building streaming applications is what is called server sent event, SSE. So the idea of a server sent event is that we have a HTTP request, and instead of getting a HTTP response, we get multiple updates from that request. So we get the first response, and we get multiple updates from the first response. And at the end, we close the connection when, for example, we have a signal from the LLM that the sequence is finished. So you can upgrade from a HTTP request to a server sent event, and this can be a very good option if you need to build a streaming application. Just to get a sense of how you would actually build a streaming application, let's look at this example of code. This is an example of a Fast API code base that would be written on the server side. In Fast API, we have what we call streaming response, which is a module that enables streaming responses and provide a server sent events capability. So here, for example, we have this asynchronous function where we are mimicking what the model would do. It would generate a prompt, so it would generate chunks of a response. And every time something is generated, we would yield the chunk, and we would provide this function to the streaming response module, and this would stream the response back to the HTTP request. So we would have multiple updates to the first response provided to the HTTP request. On the client side, you will need an API to make sure that you can catch the streaming responses. So first, you have a HTTP request that is being sent. Here, this is a GET request, but you register an event source. So an event source is a JavaScript API that enables the streaming capabilities. And you would register this event source and you would wait on update of the initial HTTP response. Most browsers enable this event source API, so you can implement this event source API on most browsers.